Hi everyone and welcome back to our series Build a Large Language Model from Scratch. In previous video, we discussed about the causal attention mechanism. Now in this video, we discuss about the basics of multi-hat attention as well as we're going to implement it using Python and PyTorch. So let us start our tutorial right now. So first I'm taking here one example sentence so that we can also see the difference between the multi-hat attention and the self-attention mechanisms. So let's say I have a sentence called she, let's say, sat by the bank of the river before going to the bank to withdraw money. If you carefully see this sentence, you can see it have the two word. It's called bank as well as this bank. The first bank word, the bank first word represent the land along side a river, and the bank which one is the second one is represent the financial institutions. It's called financial institutions like that. Its mean what are same but it have the different types of meaning as well as it have the different types of perspective, right? So as well as you can also say that this word have some ambiguous, let's say ambiguous, same word but different meaning. So imagine, you can also imagine here another word called bad. If I imagine here another word called bad, so you may imagine that if you're a boy, obviously you may say that this is a cricket bat you are talking about. Also, there is also another meaning called the creature, one kind of animal. It's called the bat. I mean, I'm talking about the Batman bat, right? So it has the two different meaning, the bat. So how are you actually using here the self-attention mechanisms? The self-attention mechanisms, it unable to distinguish this meaning, right? It unable to distinguish the meaning of the two words. It has a similar meaning. So what you need to do? We need to using here the multi-hat attention. That's called multi-hat attention. So just like the word, the bank, you can see the bank can mean the both of a financial institutions as well as the land alongside a river. So word in a sentence can have the multiple meaning, right? Depending on the context. Depending on the context, you can see depending on the context because into that the main focus of the self-attention mechanism is creating here and context factors. And that's exactly what multi-hat attention does in large language model, or you can say the transformer. It's look at the same, you can see look at the same word, but have the multiple number of perspective, or you can say multiple number of hats. See, multiple number of hats, right? So to understand different possibles meaning or role in a sentence, when we read about the self-attention mechanisms or the causal attentions, we have the some kind of matrices called the WQ, WK, and WB, as well as we multiply them with the inputs. Now, in our case, we have the same input but having a different meaning. Then we are going to using here the multi-hat attention mechanisms. Both of the things are similar, but it have the multiple number of hat. Let's say I have one self attention block. Let's say I have one self attention block. Let's say attention block. So how I need to process the multiple number of sentences, I can add here another head of the self attention block. Self attention block. It's mean I can add another self attention block to the head of this block. It's look like one kind of chain. It's look like one kind of chain. It can be a sequential or it can be the parallel. Now in this video, we're just going to see the first sequential one, that how can you actually creating this one. And after that, you're going to implement the parallel one as well. Because in the case of large language model, it basically using here the parallel types of self-attention mechanisms. So this is the main things. It's behind the scenes of the multi-hat attention that you can see. Okay. So I am just going to go on the book, that also you can see. Also one more thing, when you are going to creating the multi-hat attentions, you have the matrix called wq, you have the matrix called the wk, you have the matrix called wb. It's nothing but for the single context. So if you have the two sentence, let's say you if you have the two sentence, it's when you have the w1 q1, wk q1, and also wbb1, as well as you have another matrix called the wq2, also have the wq3, as well as it has the wqb. If you have the multiple number of sentences, I just take it here the two sentences as well. Okay, so you have the two types of weight matrix. You have the two types of weight matrix. It's when you may get here two types of attention weight matrix. Okay, if you know that what is the attention weight, right? As well as you get here two types of context vector. Context vector, because you are using here the multi-hat attentions. So if I go on the book, then you can see stacking the multiple single hat attentions. So before that, you can see extending the single hat attentions to multi-hat attentions. I just read from the book. So our final step will be to extend the previously implemented causal attention. See, we also implemented here the causal attention before in our previous tutorial, that you can see causal attentions to multiple hat, that you can see multiple hat. So this is also called the multi-hat attentions. So the term multi-hat refers to dividing the attention mechanisms into multiple number of hats. Its main is position is, see, if its position is independently, okay, independently. So in the context, a single causal attention models, or you can say module, can be considered as a single hat attention. What actually happening here actually? See, we are not going to directly using the self attention mechanisms, because we already implementing here the boxed self attention mechanisms. It's also called the causal attentions. Okay, causal attention mechanism that we implemented. So we are going to using here these causal attention mechanisms as our self attention mechanisms, and we're going to using it to creating here the number of stacked, okay, so stacked multi-hat attention. It means it has the number of hat, okay, number of hats. That's it. So we can tackle these expressions from casual attention as well as to the multi-hat attentions, right? That's it. Now what I can do is simply going to go on the book and see what is actually the stacking multiple single hat attentions layer. See, that's our input. It's called 6 cross 3 vector, that you can see the embedded input token remaining unchanged, that we already implemented in our previous tutorials. Then you can see weight matrix q1, weight matrix q2. See, instead of one value weight matrix WB, in single hat attentions, use two matrices. We just for taking sort of sake of the simplicity, we're taking here the two context. Okay. And then what I can do, we simply going to also calculate it for queries, keys, and the values, that you can see. Instead of the one query matrix q1, we have two queries matrix q1, q2, and then we simply going to calculate here the attention weight, right? You can see for multi-hat attentions with the two hats, we obtain two attention weight matrix, including causal and dropout marks. So you know that what is the dropout? Dropout is nothing but while doing the training part, some of the neurons are randomly deactivated or set to the zero. That's called the dropout, right? And the causal relations, we already discussed about that. What is the marks, what is the diagonal, how it is trie, and what is the trail, right? And then after that, we combine them with the value vector, and we got here the context vector. So our main term or the main focus, our main goal of the creating here the self-attention mechanism is to creating here an context vector that we created. But in terms of context vector, it also has the two things: context vector number one or context vector number two, because we have the two weight matrix. But when you combine them, the row are the similar, but the column are changed. The shape should be the 2 comma 6 comma 4, because we pass here 6 comma 3 three matrices, and after that, after we actually use here the multiple hat attentions, so our context combined context vector look like this: 6 cross 4, 6 cross 4. So this is dimension how it look like. Now what I can do is simply going to implementing this out. You can also read it from here. I'll give you this link to the description. You can easily grab it from here. Now you're going to implementing this out in our code. Okay. So what I can do, I am basically do the live coding, because it's very essential to do the live coding, just not showing it from your book. Okay, so that you can also see what kind of error you make occurs. Now you're going to creating here a wrapper class to implementing here the multi-hat attentions. So what I can do is simply going to creating here a class called multi-hat attention wrapper class. I already told you that this is the basics. This is the basics of the multi-hat attentions. In the later on, you're going to creating the parallel, right? So let's say n dot module. I mean, how can you parallel processing our data? Then after that, you're simply going to give it here def and init, and then you can simply going to give it to here the self, the dimension of the input, dimension of the output. Then we also have our context length, as well as you need to give it here the drop out, and then number of hats, how many hats we have, then q kb bias. If you're not if you are new to my channel, just subscribe it. As well as you are new to my channel and you're following here this series for the first time, just go back and read all of the tutorial, I mean read, watch all the tutorial, not read actually, and try to build it by your own self. Okay, now what I can do is simply going to give it to your super, and then you can simply going to give it to your init. That's it. Now what I can do, you see that the multi-hat attention is nothing but a stacked causal attention. Stacked causal attention, which can have the multiple number of hats. Which can have the multiple number of hats. So how can you do that? We can directly creating here and module list. We can creating here a module list. So let's say self dot hats, and then you can simply go to creating here and module list. So here you have our stacked causal attentions. So you can simply going to say that causal attentions. Okay. The okay, it is correct or not? See, okay, causals. Okay, so it should be the causal attentions. Okay, and then inside that is simply going to give it to here our d in and d out, as well as need to passing here the context length. So let's say context length. Okay, it should be the context length, and then drop out, and then the q kb bias should be the false, right? That's it. And now inside that, you need to also creating here a for loop, so that you can also iterate to all the hats and you can combine them. Okay, so let's say range of number of hats, how many hats it have actually. So number of hats, so it should be number of hats. Okay, cool. So now we're implementing here this self, I mean hat block. Now you're simply going to concatenate it in our forward method. Let's say def forward, and just taking the self and the input itself. So you're going to combining them with the inputs. So you can returning here torch.cat for concatenations, and you're going to concatenate the heads. Okay, so what I can do, let's say for head in self.heads, because it has the multiple number of head as well. We iterate to all the heads from here, and we simply going to passing here all of the inputs to our each of the heads. So let's say you can say that head, and inside that you're going to passing here our x. Okay, so for head in self.heads, now we can simply going to give it to here my dimensions. So let's say my dimension, let's say -1, I mean all of the columns. Cool. That's our multi-hat attention wrapper class. Simple. Now, if I go on the book, that you can see. So this our input dimensions. Let's say d in is equal to 3, and we passing to inside is multi-hat attentions. So two attention hats produced a tensor stacking the two matrices that represent the context vectors. So our output is nothing but the 2, and this output is now right now the force. How it's possible actually? Let me show you that in the pad. So let's assume that we have the two context vectors. So our input, so let's say our inputs, nothing but we have the two inputs. Okay. So what it actually do, for this two input, we have the two matrices, right? So we have the two matrices. So when you combine them and when you calculate it, we have the two context vectors. So let's say we have an input called, let's say 6 cross 3, 6 cross 3 or 2. If I see this one, yep, it's 6 cross 3. Okay. So let's say 6 cross 3. We have the 6 cross 3. So when we calculate here the context vector, so you have the context vector of 6 cross 2 as well as 6 cross 2. Two context vector, okay? Two context. It's got context vector number 1, and this is the context vector of the 2. Okay, or you can say we denote it by jat1, or you can say jat2. So when you combine these two context vector, because you need to also combine them, so when you combine them, this 6 is represented as a row and this 2 is represented as a columns, 6 comma 2, like that. So when you combine them, our row is similar, but columns is changed. We just multiply, so not multiply, we add the by the columns. So it should be the 6 comma 4. So 6 is nothing but our row and 4 is nothing but our column. So that's is happening on here. So you can see context vector right now 6 comma 4. Same thing, it's also happening when you're calling here this method that actually, sorry, class that actually created. We can also check in the shape. Now what I can do is simply going to give it here torch dot manual sheet, so that it not change it every time while we're running it. And then we're simply going to taking the batch. Now you may confused of what is the batch actually, because you're passing the data in the from a batch. So in our causal attentions, we just passing here the data in the from a batch that you can see. So batch is the number of token and the dimensions. So the batch shape of the one is nothing but our uh, the context length itself. So because if I see this, two is nothing but our batch size and number of tokens, we have our context lengths. So this is our context length. So you can say that this is our context length. Okay, and then as well as we have our d in and d out. So d in and d out. So d in nothing but 3 and d out is 2. If I go on the book, that you can see, so our d in is nothing but 3 and d out is 2 itself. But when you combine them, we have the d out of 4. But initial we passing here d out as a 2. Okay, now we can say that multi-head attention. So you can say that multi-head attention wrapper class, and you're going to passing here the d in, the d out, and the context length. And let's give it a dropout 0.0. We don't need any kind of dropout here. While we do the training part, then we may be adding here the dropout 0.1% or 20%, right? That's it. Number of hats is 2. By default, I just give it to here. We'll discuss it later on when actually implement it in parallel. Now we can calculate here the context vector. So you can say that MHA, and then you can pass in here our batch itself, because our data is coming in the from a batch. So let's say context vector. That's why it essentials to following here the full C's from the beginnings. So now we can printing here the context vectors, and then you can simply going to printing the shape. Okay, so context vector, shape. So you can say that context vectors dot shape. Boom. So then you can see that the shape is 2 is batch size, 6 is number of token, and 4 is nothing but our d out that you can see. Okay, combine them, we got in here an embedding vector of 4, d out and number of hats that you can see, d out and number of hats. Okay, because we also give it to a number of hat is a 2. Okay, no problem. We discuss this everything on later on how we got here the d out as a 4. And just initially, I just give it to here this initial manner that column is actually added like that, but it's basically coming from this side, d out cross number of hats. So the number of hat is initialized that how many hat it have or how many sentences actually coming based on that. Just for initial purpose, I just give you this kind of shortcut technique that it's nothing but the column it changes. How it changes actually basically because it changes the d out and the number of hats. Okay, fine. Now, in the next tutorial, so what I can do is simply going to implementing here these multi-hat attentions with weight split. So what's needed actually basically because up to this point we actually implemented here the multi-hat attentions, the wrapper class that you can see wrapper class. So that's combine the multiple single head attention modules. So however, that's produced here sequentially because see we actually using here this kind of for loop that you can see for loops. So in our for loop method, you also do the concatenations that you can see for head in self.heads. So we can also improve this implementation by processing the heads in parallel. Okay. So why not to accept this? This is the computing the output for all the attention head the simultaneously by the matrix multiplications. Okay. So the next tutorial we are going to implement it from scratch. So that's it for today now. I hope you enjoy this full tutorial and make sure to subscribe our channels as well as share with your friends so that they can also follow this out, this kind of awesome videos. Okay, our electricity is also gone. Namaste and bye bye.